So here we have another mechanism with two linkages. One is they're attached at point B here. So one is up here. So basically this one comes like this. And then we have an external load here at C. And it's kind of more like this over here. In this problem, the load is on the upper bar here. The upper bar is pinned to ground at point A here, and the lower bar is pinned to ground at point B, point B or point E here. So I've drawn free body diagrams of each individual linkage, and when we can either do force and moment balances on each of them individually or them as a combination. So again, I drew, here's my position vectors for all of the points in the problem. I used A as the origin, so we have B here, C, D, and E. We don't use D in this problem, but it's used in the next problem. It's the point directly below the load on the lower bar. So, and then we have our reaction forces. So here's the reaction force at where it's pinned to ground, the upper bar. Here's their internal force between the two linkages. The external load, which is acting at C in this case. In the next problem, it's going to be acting on D. And then the other reaction force over here at point E. So what we do is, what I did is I sum forces and moments on the total, and then on just this linkage. So in the total we have A, C, and E acting. So here A, C, and E, and B is an internal force that if we could actually put in B here, but we'd see that it just cancels out. All the internal forces will have equal and opposite components. And then we have forces and moments, and this gives us three equations. And then I use just this part of this linkage here, and in that case we have A, B, and C acting. So what we can do is then we get three more equations here, and if you look here we have 1, 2, 4, 6 unknowns. So we have 6 equations and 6 unknowns. And if you go through the math and solve those, we can get that in the case where in case A, where the load is acting at C, we find that our reaction forces are at A we have 2.7 kilonewtons in the horizontal direction and 0.2 in the vertical. At B, minus 2.7 in the horizontal, 0.6 in the vertical. At C, minus 2.7 in the horizontal and 0.6 in the vertical. And in the second part of the problem, we're told to move the load down to point D here, which is directly below point C, as you can see. And in that case, what we find is that the loads are generally reduced, and in fact, some of them actually, like FCY actually changes sign, because basically, I guess you have less of a leverage when you push down here than you do up here if you're trying to generate large forces. So again, it's 6 equations, 6 unknowns, and depending on which parts of the system you look at, those 6 equations and can be easier to solve. But no matter what you do, if I use just 2 here and one I would have gotten 6 equations and 6 unknowns too. But they may have been a little harder to solve, but I would have gotten the same answer.